start off my video on power by talking about the alternative hypothesis. So let's suppose that we're in a situation where it's actually true. So there actually is a difference in outcomes between the two groups in our study. So if we reject it, we're committing a type 2 error. So if we had rejected this hypothesis and it actually turns out to be true, it's a type 2 error. And remember, in my previous lecture on type 1 and type 2, I said that you should remember this by blind to the truth. So B is for beta, and that beta is a probability of committing a type 2 error. Now let's go back here and say we accepted the alternative hypothesis, and it actually did come out to be true. That's something called power, and power is 1 minus beta. See? Isn't that neat? But now to the important stuff. I mean the really important stuff. And that is what affects power. So the factors affecting power. And this is something that a lot of people think they know well, but they really don't. And I'm going to start off by dividing the factors into two. And one is the one that is cemented. And the others are dynamic and can be changed. So cemented is basically the magnitude of difference. And the dynamic ones are sample size and alpha. Okay. So to start off with the cemented things that affect power, I'm going to give you an example of two studies. One study is study A, and in this study our two groups are smokers with 100-pack year history. Another group is non-smokers who have never been exposed to any second or third hand smoke. So our study B is non-smokers who have been exposed to third-hand smoke. And our other group is, again, non-smokers, but they've never been exposed to any second or third-hand smoke. So just by looking at these two studies, study A is going to have a greater magnitude of measurable differences between the outcomes of these two groups. That's just how it is compared to study B. And therefore, you could just tell by looking at this that study A is going to have a greater power because of that. So now I'm going to go over the changeable ones, the changeable dynamic factors. So the first one is one that if you ask any basic science student, he or she will know. And that is, you increase the sample size, you increase the power. And that's something, you think that is very intuitive, because if you have more people, more numbers is power and something like that. But that's not exactly true. And this power thing, increased power with increased sample size, is generally true. There's another factor that is in interplay with sample size, and that's called alpha. So when I tell you about alpha, alpha is a criterion. Alpha is a criterion, and we commonly use 0.05 as our criterion for clinical studies. 0.05. So for a clinical study to be acceptable to us, we say that the P should be less than 0.05. And we look at a study, if P is less than 0.01, we really like that. We're happy with that. But if we see a study with P is less than 0.08, or we are very unhappy with that. But it turns out that power increases this way. So all things being equal, if you compare the study with a p-value of 0.08 is going to have a greater power, and I'm going to explain why now. This is what we call a confidence interval. That's where we get that expression 95% confidence interval, because we have the acceptable alpha of 0.05, and 1 minus 0.05 is 0.95. Okay. Now, when we have a confidence interval, we have a margin of error. We have an acceptable margin of error. So error is related to something called a z-score and our sample size. So this is n, which is the sample size, and z. Now, z-score, or z, for each confidence interval, it varies, and it varies like this. If you're at 80% confidence interval, you're going to have a 1.28 z. If you have a 99% confidence interval, it's going to be about 2.58. So there's an increase as the confidence interval increases, the z increases, and then therefore the error increases. So you want as small of a confidence interval as possible, and a large sample size. And the interplay of those two gives you more power. So say you had an unacceptable error in your study. An easy way to correct it, and what a lot of people do, is just increase the sample size, and that diminishes the error. So error diminishes with increased sample size. I'm going to just write a quick take-home message. So the take-home message is: power is defined by this, and the factors affecting it are magnitude of difference in outcome that's measurable, and sample size and alpha. And you've reached the end of my lecture.